In this video, we are going to talk about implementation of convolutional neural networks in Python using TensorFlow. So here in this portion you can see that the three important layers which are normally used in our CNN, and here is the formula that tells us the output of a convolutional layer, the output size of a convolutional layer. So first of all, we will see in this implementation the data set that we are going to use here. The data set we are going to use here is Fasion Mnist, and shortly we will see some inner details about this Fasion Mnist. But before that, we need to import important libraries to implement our CNN. So here we will import TensorFlow, and then after that we also import Keras, and some other layers that we already mentioned in our previous tutorial of neural network implementation. Then there are some other libraries. We import layers, models, and datasets. So normally many datasets, many publicly available datasets, they are present in datasets library here. So it can be used to import those datasets like Fasion Mnist. So now all of the important libraries, they have been imported. So now we will see the data set we are going to use. So if I run this one, datasets dot Fasion Mnist dot load data. So by using this load data, we can load Fasion Mnist dataset in these variables. So this will get training data. This variable will contain labels for the data. This is test data, and this has labels for the test data. So if we run it, so since I have already downloaded that data in my local library, in my local directory, so it has read that data set and assigned it to these labels. But if you are going to load this data for the first time, it might be possible that it will load it from an online repository. So you have to think about it. Now we want to see the shape of our data set. If I run this one, so this is 60,000. So it has 60,000 images, and each image is of size 28 times 28. And just to look at the different images or objects in this data, if I run this one, like let's see the image at 150 index. So here it is. So you can plot different images. If you again go back to my neural network implementation tutorial, I have plotted a number of images in a dataset. That dataset was about Mnist, but here we are using Fasion Mnist. And if again we want to see how many classes do we have, so it can be seen by looking at the number of labels. So for example, if we look at training labels, if we look at its shape, again we have 60,000 labels, but how many classes do we have? So we need to look at the unique labels which are inside this variable. So for that we can use unique. So this is giving us 10 labels starting from 0 to 9. So it means we have 10 classes. So it also means that for our output layer, we need to have 10 output nodes if we have to classify 10 classes. Since we are interested to implement CNN, so we will look at how many layers we are going to use and how to implement any particular CNN layer and pooling layer. So first of all, if we have our first CNN layer, initially we will instantiate a sequential model from our models object. So sequential will give us, I have named it with my CNN model. So run it. So now I can add different CNN pooling and dense layers to my CNN model variable sequentially, because this is a sequential model. To add a convolutional layer, we use layers.conv2d. Now, how many filters we are going to use? The first argument. So 3 means we are going to use 3 filters. What is the size of filter? So it can be set with this argument, with this parameter kernel size. What should be stride? Stride is here. We are using stride of 1. And padding. What type of padding we are going to use? So padding has two different values, valid and same. So if we use here same, then it means that the output of a convolutional will have same image size as the input image size. And if we use valid, so it means that it will calculate the output size of the image by using this formula, this one here, this formula, n plus 2p minus f over s plus 1. N means size of the input image, p means padding, f means size of the filter, and s at the denominator means stride value. So here we are using padding value with valid value. So it means that we will calculate the output size of the image by using the above formula. Activation function we are going to use is relu, and input size. So since this is a convolutional 2D, we are using here conv2d. So, and this is the first layer, so we have to specify the input shape. Now here input shape we are setting here is 28 times 28, that is according to our input image Fasion Mnist dataset. Each dataset has a size 28 times 28, and this is the channel that our input will have, how many channel our each input sample will have. So since each input image has one channel, so here we are specifying it by 1. And after that we add pooling layer, max pooling layer, and max pooling layer has default value 2 by 2. After that we add another convolutional layer with 10 filters. Each filter has this size, and activation function this one, and max pooling layer afterwards. Here we are particularly explicitly specifying the size of pooling filter. We have third convolutional layer, then max pool layer, and after that we have a fully connected layer. So before adding this fully connected layer here, this is our fully connected layer. So before adding this one, we need to flatten our third convolutional layer. Whatever the output we get, we need to flatten it. Means we convert it into a one-dimensional vector. So that is the meaning of flatten. So we flatten it with the help of this function, flatten. And after that, we add fully connected layer. So here is first fully connected layer with 40 nodes. Activation is this one. And here is our output layer. So layer dot tens 10. Since number of classes are 10, number of classes is 10. So we use dense with 10 number of nodes, and activation is softmax. So we run it, and after running it, we look at the summary. So here is the summary of our convolutional neural network. Now we want to compile it with optimizer, a loss function, and matrix. So now before using this model, we need to do some pre-processing, a little bit of pre-processing with our data. So first of all, we normalize that data, because if we look at the values in values of pixels in each image, so they are between 0 and 255. So to normalize them, normalization means convert all the values between 0 and 1. So instead of having the pixel values of an image between 0 and 255, we need to have them in the range of 0 to 1. For that purpose, we normalize our training data and also test data. And again, since our input image, our input dimension, if you look at here we have specified the input dimension as 28 by 28 by 1. So 1 is the number of channels. So we also, while our image has this size 28 by 28, so we need to reshape our input data. How? Because for each image dimension should have 28 by 28 by 1, so that it is compatible with whatever the input dimension we have specified here for our CNN input layer. So to do that, here we are reshaping our input data. So training data reshape, all the images we need to reshape. From 28 by 28, we need to convert it to 28 by 28 by 1. So now if we look at the shape of each image, now it has converted to 28 by 28 by 1. In the same way, we make same changes with our test data. Now we train our data. I have already trained it, so you can train that data, and then you can plot validation loss and training loss here. So that's it.